Now let's talk about the first best practice. Evaluate and optimize your RAG agent end-to-end using reference-free RAG triad evaluators, focusing on groundedness and relevance evaluators. Complex queries are a common scenario for RAG power agents. Agentic RAG is an advanced RAG patterns targeting these scenarios compared to traditional RAG patterns. By using the Agentic Retrieval API in Azure AI Search, we observe up to 40% better relevance for complex queries than our baselines. In this demo, we'll use this Agentic Retrieval API to show how to run Agentic RAG and evaluate its performance in Azure AI Foundry. So, what can Agentic Retrieval do? Agentic Retrieval engines like Azure AI Search and Foundry are designed to extract grounding information from your knowledge sources. One of the most useful features in Agentic Retrieval is that it performs a step-by-step execution plan for the advanced agentic RAG pattern. First, it breaks down complex queries into subqueries, and then it retrieves relevant results from different knowledge sources, and at the end, synthesizes the different results into a complete unified response. This means agentic retrieval does more than traditional search engine. Its synthesis mode also supports end-to-end question and answering. We're going to use a notebook to illustrate how it handles complex contextual queries within a conversation. This is a notebook to demonstrate how to evaluate and optimize RAG agent using agentic retrieval in Azure AI Search. First, we're going to have a Earth at Night search index based on a knowledge source about Earth at night. We will create that knowledge source that targets the index, and then the knowledge agent that targets the knowledge source, and an LLM for query planning and answer synthesis. At last, we can use the agent to fetch, rank, and synthesize relevant information from the index. With the preparation step that we have done, now as a developer, I want to put in some test queries to this agent. First, I use the question, why do suburban belts display larger December brightening than urban cores even though absolute light levels are higher downtown? This query apparently is very knowledge intent specific to the knowledge source. After the knowledge agent came back with an answer, I can continue the conversation by following up with another question. Which suburban area show the most significant changes in light levels over the years? With these two queries and two responses, I'm interested in evaluating the quality of them. We can simply use this snippet to provide the relevant input query, context, and response parameters into the groundedness and relevance evaluators. And then I can submit a batch evaluation to Azure AI Foundry and follow the link to navigate to the portal. AI development teams can use Azure AI Foundry portal to visualize batch evaluation results and assess the answer quality of their knowledge agents. Now I can use the report page to see the entire dataset report on the passing rate of groundedness and relevance. And also I can see the descriptions for each evaluators that I have selected. I can also click on the data page and see turn-by-turn results. Here I see for each query, I have a clear indication of pass or fail for the groundedness and the reasons provided to justify for that rating, and for relevance as well. Now that we have measured the quality of my agentic RAG pipeline, how do we optimize it? To fine-tune these parameters, AI development teams should first evaluate the quality of the current set of parameters using these end-to-end RAG evaluators, such as groundedness and relevance. In this particular case, I'm using a reranker threshold equals to 2.5. This is a key parameters, along with others, that heavily influence how aggressive the agent is in re-ranking and which knowledge source it queries. Other parameters include the target index and the knowledge source parameters, as we have created them in the preparation step. After evaluating one set of parameters, we should simply repeat the exercise with another set of parameters of interest. By performing comparison across different parameter set, developers can then optimize the agentic retrieval with respect to their enterprise data.